Hi, welcome to Chemistry Cooking. Today, WJUSTDA and two boys in a mom production brings you chemistry concepts using cooking concoctions. So this semester, we're going to try and do a little distance learning and explaining concepts, chemistry concepts using regular routine kitchen things. Today, we're going to be talking about conservation of mass. We have two helpers today. For conservation of mass, it means that everything that goes into an equation also comes out of the equation and nothing is lost. Today, what goes into our equation is going to be represented by Garen. He's the reactant side. And everything that comes out of the equation is going to be Marcos with the product side. And our arrow that says the difference between the reactants and the products is going to be represented by our microwave because we're adding heat today. Okay, let's get started. First, today we're making Rice Krispie treats. And we have to have a lot of products, a lot of reactants. For our first reactant, we're going to give our reactant supervisor the bowl. Our first reactant that we're going to do is 256 grams of marshmallows. Dang, that's a lot of marshmallow. I know, it's 2 cups. So we're going to put that into our bowl. Boop, 256. Then our second reactant for this equation is 21 grams of butter. Okay, that's just fancy way of saying like 1.5 tablespoons. Remember, you guys can do this chemistry concoctions at home too. Your tablespoon looks like this. It's a big spoon. Okay?
It's yummy. Yeah.
Okay. And then our third reactant for Rice Krispie treats, and it's 384 grams. We're going to put that. I put a little bit of chocolate chips in there, chocolate chip Rice Krispies, Cocoa Puffs. Sorry, Cocoa Krispies. Cocoa Krispies because we're going to mix them up. Okay. Our fourth reactant are chocolate chips, and we're going to add 28 grams of chocolate chips.
Yum.
Yum. And our fifth reactant, what we're putting in today, is another 28 grams of Reese's. So let's kind of review. Garen, what do we have as far as in our equation, Rice Krispie equation? What do we have?
Marshmallows.
Good.
Butter.
Good.
Rice Krispies, obviously.
Yes.
Chocolate chips.
Excellent.
And Reese's peanut butter chips.
Yeah. Okay, now remember, all these reactants are churning. Okay, they're already reacting. We're going to put them in the microwave. We're going to put in our time for 90 seconds. Boom, we added heat. Now remember, this only goes one way. If you guys ever see in a chemical reaction an arrow that is double-sided, you probably can't see that, but it's double-sided, it means it's reversible. The reaction is reversible. This one, there's only one way. We can't have a Rice Krispie treat and divide it back into the ingredients or the reacted parts. So we're going to go ahead and divide it out. Boop! And what comes out? What?
Whoa!
I know.
So fast.
We have 2 products coming out. Okay, product side. We have, for our products, after the heat and after all of the elements, or the Rice Krispie elements did their thing, and we added our microwave, we have 710 grams of Rice Krispie treat.
Yeah, but Mom, that doesn't add up. Yeah, Mom.
It doesn't. And you know what? You are brilliant, my friend.
Thank you.
The reason why is that sometimes it mixes, your reactants mix in different ways. So some of the reactants stayed in the bowl. In fact, if we weigh this out, 7 grams did. So in the law of conservation of mass, it says that whatever you put in, the weight, you get out. Okay, so if it doesn't work out, it was lost somewhere. And actually 7 grams was lost to the bowl. Okay, so that's 7 grams we can't get back. But it doesn't mean that it just went away. It means it went someplace.
Whoa.
So if we review, we had 720 grams that went in, mixed into the microwave, we added heat, and we got 720 grams that came out. Okay? And that, my friends, is law of conservation of mass. Have a good day, guys, and I'm going to talk to you guys soon in a couple minutes, and we're going to review. We miss you guys, and hope you're staying well and happy. Bye.
Bye. Okay. Hi.